Okay, here we have got a problem on conservation of angular momentum. A cylinder with moment of inertia 3.6 kg meter square rotates with an angular speed of 22 radian per second about a frictionless vertical axle. A second cylinder with moment of inertia 0.83 kg meter square initially not rotating. Okay, so that's this diagram. Disc 1 is rotating but disc 2 is at rest. Drops onto the first cylinder as shown in the figure. The two cylinders eventually reach the same angular speed Wf. So it's asking us to calculate the angular momentum of disc 1 before disc 2 was dropped. So for disc 1 we have got the Wi, angular velocity in the beginning, that is initial, is 22 radian per second, and its moment of inertia for disc 1 is given as 3.6 kg meter square here. Okay, now it's asking us to calculate the angular momentum. So the formula for angular momentum, we will write it as L1. Let's write it as L1I to make it very clear that it's the angular momentum of the first disc initially, that means before the second disc was dropped in. That will be I1 Wi, and that's 3.6 multiplied by 22. That gives us 79 kg meter square per second. So that's our part A. Calculate the angular momentum of disc 1 before the disc 2 is dropped. Now in part B, it's asking us to calculate the angular speed of the system after the disc 2 is dropped. So you can see after it is dropped, both of them are going to move with the same angular speed, that is Wf, and we want to find out what is this Wf. So for part B, we are going to use conservation of angular momentum. So sigma Li equal to sigma Lf, which means that the total net angular momentum before is equal to total angular momentum after. Let's do that. So before we had only disc 1 rotating, so we'll have only the angular momentum of disc 1, which is 79. Okay. The angular momentum of the second disc initially was 0, because we can see that initially the second disc was not rotating. So that's only the first disc which was rotating. So 79 equal to in the final state, that means after the disc 2 is dropped, both of them are going to have the same angular speed, but we have to add their moment of inertia. So I1 plus I2 Wf. 79 equal 3.6 plus I2. Let's check what was I2 here. 0.83 multiply Wf, and we get that as, if we solve this, we are going to get Wf as 18 radian per second.